Hello and Namaste. Today is the fifth lecture of the module 1, wherein basically we would be looking at how we would really create thematic maps, what kind of maps we would create, and what are the basically how do we do a data investigation, how do we look at GIS software, what are the software integrations that are needed. So all of these is extremely important for you to understand how maybe the last part of the information that is actually delivered. So when I speak about data investigation, it is about how and why it is actually necessary to do this. Then when you look at thematic mapping, it is to create a theme based output. For example, whenever you look at any of those data, most of this data, if it is statistical, qualitative, quantitative data, most of it data if I say a quantitative data, so this data is in the form of numericals. So instead of giving numericals for people to understand, it may be given in the form of a thematic maps. For example, if I am trying to represent the entire India's population based on every state, so instead of giving every state a value something like this, 35 lakhs, 40 lakhs, maybe 1 crore, 2 crore, 10 crore, 20 crore, 30 crore. So instead of giving it something like that, we try to look at as a thematic maps. We give a range. So for example, a city which is between maybe 1 crore to 5 crore population is in this color, 5 crore to 10 crore, that is what is called thematic maps. So we look at what are different thematic, what is how the thematic maps looks. We'll also create thematic maps when we are looking at hands-on practicals. So we look at the software part of it and some integrations that we can do as a software. So when we are looking at data investigation, the very important part of it is it includes visualization. So when I say visualization, so when most of us create data, the data is in the form, maybe in the form of a numericals, maybe in the form of a readings, etc. So it has to be visualized, otherwise you will not be able to understand what is the quality of the data. Is everything correct? Just by numericals, no ordinary citizen would be able to understand what is that data all about. If you are representing a rainfall with certain information, so if it is in the form of a visualized information, it is easier to interpret for anyone. So you can even give a red color for the most very heavy rainfall, and subsequently use an RGB format to, whereas a blue representing the lowest rainfall. So that gives the information in a much better way, much pleasing way, and people can understand and interpret it in a much easier way. So this is about manipulating, and next is the querying of data. So when we look at querying of data, I did explain that whatever the size of the data you have, whether you have a single data set, multiple data set, or multiplicity of the data, so this data can be queried by a single instance. So the single query can be easily done across by building a relationship among them. How do we define relations? That's what we have to learn in further slides. But when we look at this entire database, wherever the data is there, whether it may be somewhere in the central repository, so you have to just connect to that data, use that data as a source, and you can do the query and do any analysis that is necessary for your interpretation. So investigation in GIS can be map or feature based. I'll speak about this. It can just the investigation can be based on how do you create maps, different thematic maps, different land use maps, and the information can be derived based on it, but it can be also feature based. When I say feature based, these are the things that are based on the data that is collected in the database. So you, based on those features in the database or feature structures in the database, you query. So these are investigation based on feature based. So when we look at map based, includes any classified information. For example, when I say classified, it is classified based on classes, based on sectors, themes, and many of them. So various attributes and comparison of its structures. When I say feature based, it involves attribute that is based on a database, or it can be on a spatial data itself. So spatial relationship is such as proximity, etc. So these are the queries. For example, if I say yeah, I have a map of this particular region, maybe Kolkata, let us say. So if I am sitting at a particular block, let us say a block in Salt Lake region. So if I am querying that within my 5 kilometer buffer, what are the tea shops available for me to have a cup of tea? So this can be easily done using a feature based analysis. So that is called proximity. So I did define the proximity in my previous lectures. Maybe in the third lecture I did even show you about the proximity map. So that's how you create a feature based attribute information or attribute data based analysis. So these are some examples of how you do it with feature based, but the very important aspect is map based and feature based both can be combined together. So if these are combined together, then only it becomes an extremely powerful tool for any kind of analysis. Name any kind of analysis, you can do it both feature based and map based. So when I say map based, for example, when you look at these two maps, at the first instant what do you understand? Because when you look at this map, the first thing is I have added it as it's a satellite data from Landsat 8. Okay, it was acquired on 11th April 2013, and the other one is acquired on 25th April 2018. So these are two data sets. This is a satellite map of Delhi. So when we look at this, normally if anyone who is accustomed to looking at remote sensing data, they would very clearly say these are the ones, the city region that is there in Delhi. Whereas when you look at the same city region has grown over here for the entire Delhi region. If you see, this is the entire Delhi. So this is what is actually referring as a urban area. So these are some of those maybe sparse vegetative regions or even the thick vegetative regions that are there. When you go to the field, you will understand what kind of vegetative region is there. You can even find a lake, a water body here. So somewhere here, sorry. Okay, and this is a region which is extremely thickly urbanized. If you see this region, this was a urban area, but when you see here, it is extremely urbanized in 2018, and this is the water body that is flowing across. So when we look at this two data, if I say this is from Delhi, so you know what is the geographical location of this data. And the most important thing is, whenever you are looking at a map based investigation, first thing is observe what is there in the map, what are those colors representing. So go back to the electromagnetic spectrum and look at how different spectrums, each of the properties of the map is actually varying. For example, if you are looking at level 2 classification of remote sensing data, which means you have urban, water, vegetation, others. Let us say that is my land use classes which I am trying to understand. You have to go back to the spectral sensitivity or the reflectivity of each of these land use classes and look at how in which region actually the reflectivity is good, so that it can be captured. So when we are looking at the characteristics of the spectral reflectivity, based on that you create a composite data which is being represented here. Okay, so if someone want to understand how it is being done, I would suggest to take up a remote sensing course, but as of now just understand this is a composite image. Okay, so when we have a composite image, so we, based on what kind of composite it has been defined, we can understand what are these properties that is actually referring to. So that is how we observe. That's the first step of understanding any map based investigation. Without observing what is the quality of data, how is the data, it cannot be, the map based investigation cannot be done. First step is look at metadata, then come here, look at every feature based data, then look at what it describes. So if there is some map that has been given to you, look at what it describes. It may not describe only one factor, it may be defining various other factors. So how it is describing, what kind of description it has to be looked at in more detailed way. So look at, okay, let's say that if there is a road layer that has been overlaid on this in case, okay, so why that is described here, what are the descriptions that are there for the map, why the road layer is overlaid, and if there are certain descriptions of that road layer and the analysis that has been done, why it has to be done. Then you can, then is the compare. So when you look at this data and look at this data, the first thing I did observe here and compare is how the urban growth has happened from 2013 to 2018. So how, the first thing is look at observe it, then look at describe it, then look at comparing it. So this gives you the real world information from that data. And mind you that any of these data that you have collected, it is very necessary to do a validation on site. If none of this data are validated on site, then probably you are actually giving a garbage output. So if it is really validated, the output is really very significant. So once you compare it, the next thing is analyzing it, why, how, and why it has happened, that why that process of transformation has happened. Is there the industrial area has come up, is there the density of population has increased, is there because of the housing societies have come up, are there certain for example city development plans that were put in place because of which it came up. So all of these analysis can be done using the next part of the information. And finally, the reflecting this information in terms of a report or a thematic map or any other kind of maps is the last part of data investigation. So this is about the map based investigation. And when we look at feature based is, first thing is, what are the different layers you have, okay. So look at the layers and its attributes. Every layer, every attribute may not be useful to you. So what are the different layers and attributes that are present, what it indicates, what's the format that is there, and what kind of information that it gives. So these are the things that you should be familiar with. Then locate labels. I didn't explain about the labels in my last class. Locate those labels which is linked to these attributes. So once you have located those labels, it becomes more easier for you to understand what kind of data it is and how it can be used. Then identify features relating to the attributes. What are different features, how it can be related to the attributes, how these attributes can be an helpful aspect in identifying any of those information in that particular map. Then combine features based on any common attributes. For example, if there are certain features which can be combined, which can be indicated with a common attribute, you can combine it. That is based on the feature, that is what is the speciality of a feature based investigation. So when you have a feature based investigation, couple it with a map based investigation, so that gives you an excellent output, and coupled with your surveys or your validation on the ground will actually give you an extremely important data set or output that can be visualized. So if someone asks me, okay, I have done all kind of data generation, I have analyzed the data, I have done everything, what's the last part? The last part is, you can put it out in a various ways. One is you can put it out a quantitative data, you can put out data in just a numerical format, but when you look at this, any common man can understand it more easily when you have much more a thematic kind of analysis, which means you have colors which are actually representing different themes. So for example, here there is a thematic map. This is about what are the different trees that are there in this particular region of Hutur village. And when you look at this, what is there an agricultural cropping region in this? Now if I create this map, let's say in 1996, if I recreate that map in 2006 and then in 2016, we can see the change that has happened in this particular village. For example, here the pink color shows the eucalyptus species that is there in this particular region. So where it is where it is there can be easily seen. So anyone who is looking at this particular map, if just by looking at the GIS system, can say that okay, these are the places where eucalyptus trees is there. There is Pongamia species, so you can look at this map and say yes, this is a region where the Pongamia species is there. And when you look at acacia is also available in this region in a greater extent, so that it can be easily identified. Instead, if you just give a plain map or a quantitative figure, people do not know geographically where it is located, how what is the extent that it is located. So when you look at temporal data, maybe a data that is spanning maybe 20-25 years, so you will not be able to understand how either it is degraded, how it has improved, what is the change that has happened. All these things cannot be possible. But once you create this thematic map, right, so once you have created this thematic map, it is very easy to understand what kind of data you have, what are the changes that is happening, and what is the information that has to be supplied. So this represents the number of trees that are there other than the species that is mentioned here. So for example, there is Tamarindus indicus in which is a major part of this region. You can see here it is all these are Tamarindus indicus. So when you are looking at this, you get a feel that okay, this is there in this region, and if you go to the field and locate this information properly, validate information, this can be very important information for any of those, for maybe forest department or an horticulture department. So so this is how the thematic mapping is done, and is extremely useful in terms of looking at the change, giving information to the user, giving information to a common man, and can be extremely handy. If you are looking at theme based information, for example, people say okay, you have one image, you are looking at temporal data, so that's fine. So but theme based information also can be used for visualization of various aspects. For example, visualization having a topography, infrastructure, soil, land use, geographic reference, anything that you name. For example, on your left hand side, you are looking at one of the images which is actually representing how this information can be extremely useful when you are looking at theme based visualization. For example, you have this real world, that is the normal, let's say it's a normal region in IIT Kharagpur. So when you look at this, you have one layer that we have already generated a geographic reference. That's a very important part of the first layer. Then you have land use. This also has the same geographic reference, and it is representing what is the different land uses in the campus. It has buildings, it has trees, it has parks, it has open spaces. Okay, so it has some agricultural cropping region. So all these things is represented in land use. Then you have soil, what kinds of soil is there in which part of the campus is represented here. Then there is infrastructure. If there is road infrastructure, if there is rail infrastructure is right next to the campus. There is a lot of road infrastructure inside the campus, extremely good infrastructure. So that is also that is mentioned here. Then the topographical analysis, when you see this, see all this data are linked with a common geographic reference, which means all of these have a common geographic reference, which actually helps in theme based visualization, theme based analysis, theme based outputs. So if someone wants to clearly locate any place in the campus where the next infrastructure can come, if they can drill down the entire data set, okay, so they can easily identify where the infrastructure is there, where you have forests, where you have extremely important structures, and where the new infrastructure has to be placed. So it is much easier for a decision maker to understand what kind of infrastructure is there and how do you develop this. So GIS actually simplifies the real world just as maps. You can create the real world in terms of maps. Look at the maps, you understand the real world. So one very important thing is it can handle data management in a very good way. Thematic maps, geostatistics can be easily done with all of these layers. strategic level assessment can be easily done. So I was explaining about these layers. If you see the figure on the left hand side, that's the real world. When you have thematic maps that is already generated, for example, I did take examples of topography, land use, geology, soil maps, then any of other thematic maps, along with maybe certain other scenarios. So for example, what if in case there is an infrastructure that comes up in this region, what is the change that happens? What if there is a plantation that happens, what are the changes that needs to be done elsewhere? What if there is an residential complex that comes up here, or maybe a shopping region that comes up in this particular area? What are the changes that happens? That is what you can look at the strategic level before planning that infrastructure on the ground. So this is where the simplification of the real world can happen with using a GIS. So when I say GIS is always a part of decision making. Any decision that has to be taken, GIS would be a part of it. First thing is the formulating a question, then observe or acquire data. So when you are trying to look at any of GIS systems, first thing, as I did speak in the previous class, is acquiring the data. So then analyzing the problems. So when you are observing a data, it can be ground based data, it can be ancillary data, it can be socio-economic data, it can be geospatial data. So all of this data, spatial and non-spatial data, come into it. So once you have observed the data, you analyze a problem, you seek a solution, and you mitigate a change. So this is how the entire chain of this is how the GIS will be extremely useful. So GIS gives you this data, generation of data and acquisition of data can be done, and data can be stored, data can be analyzed, data can be analyzed for solutions, and finally planning to mitigate the change. That is how GIS is a part of decision making process. Now database GIS can be a decision support system. As I said, for example, let us say that we have certain geographic data sets, we are planning an infrastructure. So when we are looking at the infrastructure, we look at how, if in case this infrastructure comes, what kind of change that will happen. Let us say there is a certain green region, extremely good. So it would become extremely necessary at certain point of time that you have to get certain infrastructure only at that place. So in case you, let's say you plan an infrastructure there, so GIS can help you to understand if that infrastructure comes in that place, in the surrounding regions, what are the things that may change. For example, let's say there is a housing complex that has come up in that region. So housing complex needs to have certain amenities that supports that entire housing complex. So what are those amenities, where it may be placed, how it may be placed, whether how it affects that particular region. All of this can be understood with the GIS, with using all your map support. So with that, it means to say that you are actually capturing the entire support system of that process. You are designing the entire support system. Based on that support system, a decision would be arrived at. How is the decision arrived is up to the decision maker to understand what is the kind of process change and how it is implemented. So with this, it may be an effective support tool in order to understand what are the changes that is happening in the real world. So when we look at all of these, the one thing that student asks, sir, what are the GIS softwares that are available? So if let's say you want to buy some commercial softwares, you have enough research fund to buy commercial softwares, then you have extremely good software, something like ArcGIS. Is ArcGIS. As I said, it is extremely good. It can handle any kind of data, any big data, small data, whatever it is that is available. Even it can connect to online data repositories, collect data from it, analyze the data. So ArcGIS is extremely good in terms of looking at data. So it is from the Environmental System Research Institute. This software can be used. Then you have AutoCAD Map 3D and Autodesk Geospatial. has become a very promising software in terms of deriving geographic information. Then you have Bentley Map, which can give you map based inputs in terms of how geospatial data is used for map in decision making. Then you have Integra for hexagon geospatial, which has gotten GeoMedia. GeoMedia is extremely capable of analyzing the geospatial data. So if someone wants to look at very advanced models, advanced instances of working, GeoMedia can come in handy. Then you have Global Mapper. Nowadays people have started using Global Mapper in a very large way, extremely efficient. Whitney Bowes Map Info is another software which is extremely good in terms of, in case you want to have a simple interface and look at various aspects of GIS tools, then Map Info can be one which can help you out. And you have Maptitude. Maptitude is another software which actually specializes in tools, different geographic information science based tools, so that can be used. Then you have Terrasset, Clark Labs. So this was previously called as Idrisi, but now it's called Terrasset. Terrasset is in fact one of the comprehensive softwares which has both capability of using any kind of models, data models that are available in GIS system, and can be extremely handy when you are trying to even model and visualize a particular environment or a particular system. So the Idrisi or Terrasset can be extremely useful. And coming to the next set is the open source software. The very well known, the most funded and developed software is GRASS. So it is from Open Source Geospatial Foundation. So GRASS is one software which can handle any kind of data very efficiently. So if someone wants to learn how to handle a remote sensing data, how to handle a geographic information data, GRASS is one tool that everyone has to learn, because rather than a commercial software which is under a packet, so you input a data, you get an output, whereas GRASS will deliver a stepwise data output, which means to say that you learn how the data is transformed from data to information. So that is where the GRASS is extremely handy. So the other good software is GIS, but GIS is a kind of a very close-ended group, but it can be used for various aspects. Quantum GIS is another software which I would recommend everyone to use here. It has extremely every capability of any commercial software, anything you name it. So Quantum GIS can actually handle. Then you have Ilves. Ilves was one of the first of those softwares which were developed, which were extremely handy in handling the geospatial information. OpenJump is another software. If someone is interested in advanced analysis, OpenJump and Saga GIS are quite efficient in handling any type of geospatial data. But I would suggest GRASS and QGIS as some of the best combinations that you can have in the geographic information system, development of our understanding of geographic information system. So in case you want to integrate GIS, web and any wireless information technology, then you have Google Earth. So Google Earth is one of those places where you can learn. I would suggest everyone to download Google Earth, look at Google Earth. There's a host of information that is there. Please download the 3D version of Bhuvan and look at it. It gives you a lot of information, lot of data that is available. Then you have Skybox imaging. So these are certain places where you can get a huge lot of data. So this and screen of Microsoft Visual Earth. So this also kind of a web based browsing system where you can understand, visualize different earthscapes in using a browser. So I have already spoken about OpenStreetMaps here. So on your right hand side, as I speak, you can see the data that is there on the India's OpenStreetMaps, that is that you can load it directly onto your QGIS. So just loading onto QGIS, then extract this data from the QGIS for your analysis can be done with all this data. So data is available there, so you have a software which is capable of extracting this data. So that is what is most necessary of today's context. So we have learned, as a summary, we have learned today how what do you mean by query, what do you mean by filtering and visualization of map based data. We have seen how GIS can be a process of decision making, and we have looked at GIS softwares, both commercial and open source softwares, and how the data integration can be done with web applications, for example Google Earth or Microsoft Visual web based applications. I would say please go back, look at all these web applications for some time. Even if you are looking on a mobile data, maybe it takes a bit of time to load, but it is very useful to see these applications so that you understand how GIS data is there. So finally you have we ended the class with useful web tools, WebGIS tools. I would also take up some aspects of WebGIS, how do you actually build it, in my last class of this particular course. So thank you very much.